In the last video, I started with declaring and initializing a variable with a type of java.util.ArrayList. I showed you how to create what Java calls a raw version of the array list, which simply means I didn't use a type argument in the declaration or the creation of the array list object. It's common to find the raw version of the array list in older legacy Java code, because there was a time when the raw version was all you had to use. In general, you'll want to always include a type argument when using the array list. Before I start reviewing other methods on array list, I want to revisit a very common mistake that can be made using array lists. Remember in the last video when I said that you should declare an array list with a type argument, as I did in this code using grocery item. These angle brackets, by themselves called the diamond operator, can be used when Java can infer the type, as it can in this declaration and assignment statement. But if I forget the diamond operator in the instantiation part of this statement, I'll get another warning from IntelliJ about the raw use of a parameterized list. Hopefully you'll remember that this means the compile time type checking won't occur, so without using the diamond operator, I'd be allowing other types to be potentially included in this array list. If I remove the diamond operator, you can see IntelliJ warning us about this problem. Okay, so I'll revert that last change. It's a good idea to pay attention to IntelliJ's warnings and to resolve as many of these types of warnings as you can, because IntelliJ encourages best programming practices, and best practices are something you want to strive for. Ideally, you want to aim to remove all IntelliJ warnings. In many cases, IntelliJ can actually fix the problem for you if you don't want or know how to do it yourself. You saw me apply an IntelliJ fix in the last video. In this code from the last video, I used the add method without actually discussing it. This is the simplest form of the add method, which adds an element to the end of the list. Let me print our grocery list out now. For an array list, you can simply use println passing the array list instance. This avoids the necessity of having to use a helper class like we did with the array. Let's confirm this really works. And when I run that, and that's confirmed, the output shows my list, which has one grocery item. I'll add a few more items to the list. I'll add a milk grocery item. And I'll add an oranges grocery item. And running this now, I get all three items in my list printed, butter and milk, both in the dairy department, and oranges in produce. What if we want to add an entry at the start of the list? I can use an overloaded version of the add method for that. I'll use add again, but we'll specify an index number, 0 in this case, to indicate the first entry. And I'll use apples as the grocery item. This version of add takes an index as the first argument. Instead of adding this new item to the end of my existing list, it will instead add it at index 0, moving all the other elements down. Before I run that, I'll simplify how the record gets printed out. Going to my grocery item record, I'll add my own toString method to this record, add override. I'll type this manually instead of using IntelliJ's code generation. I'll return a formatted string containing count, name and type. I'm overriding the toString method and returning a formatted string using string.format that has 3 specifiers. The first specifier is for an integer, the count, and then I have 2 string specifiers, the first for the name which I want to be uppercase, and the second is type. And if I run that, you see that 6 apples in produce were added as the first list item, and the output is a bit easier to read. I can use the set method instead of the add method to replace an entry. Let's give that a try. You can see I have now replaced the butter item with 6 apples. I can also remove an item by index, so if I wanted to remove milk from my list, I could pass 1 as the argument, which means the second element. Like arrays, array lists also start with an index of 0. I'll add the call to the remove method. You can see confirmation that milk has been removed from the list. I need a new class for the next block of code. I'll add it to the same package and call the class moreLists. I want to start with a string array with some groceries we might buy. I'll create a new string array called items with 4 elements, apples, bananas, milk and eggs. I'll create a list of type string and use list.of to return a list of the strings I just created, and print the result. First, I have an array of string with 4 strings in this array. Next, I'm using a method on list which is a factory method. I've talked about factory methods previously. This is where you can call a static method on a class and it returns a new instance of something back to us. Here I'm calling a static method on list, simply called of, and that returns a list of string elements back. And I'm assigning this to a list variable. Notice I'm using the type argument string on the left side in the declaration of this variable. Now list is not array list, and there's a reason why I'm not assigning this to an array list of string. That's because the object coming back from this method isn't actually an array list. Let's run this before talking further. I get a nicely printed list of our array items. So this method transformed an array of string to a list of string. Let's explore what kind of object we're getting back from this static factory method. I've shown you previously that we can do this by calling getClass and then chaining getName to that. I'll print out those calls to see what is returned. The getName method gives me a little extra information, as you will see. As you can see, this list is something called java.util.immutable_collections$list_n. Okay, so what is that? Well, the list I'm getting back is of type list n, and it's a nested class within the immutable collections class, but most importantly, it's immutable. And don't worry, I'll be talking about nested classes later in the course. Let's test if it really is immutable by trying to add an entry to it. I'll attempt to add the string literal yogurt to it. If I try to run this code, I get an exception, an unsupported operation exception. So why would I show you a method to get an immutable list? What value is that to us? Well, as it turns out, this method can be used in the creation of an array list to make populating the array list a bit easier. I'm going to remove those last 2 lines of code I added. I'll then type the following: array list of type string, which is done using these angle brackets, groceries equals new array list, diamond operator, and list in parentheses. I'll add the string literal yogurt to groceries and print it out. Here I'm creating an array list of string using the variable groceries and assigning a new instance of the array list to it. And notice the diamond operator there. As I discussed in the previous video, I could have included the type string in there, but it's not required as it's inferred by Java. It makes the code easier to read and faster to type out. This code is calling a constructor on array list and passing an argument, the list I created above. The result of this instantiation is a new mutable array list, populated with the elements from the immutable list I passed. And to prove this list is mutable, I'll add a new element, yogurt, then print groceries out. I get the 4 items I had plus yogurt in the output. Looking back at the list.of method, it's overloaded and supports different versions including variable arguments, which I talked about in a previous video. I'll simplify this code and create a list with specified elements all in one statement. Let me show you what that looks like. Array list, angle brackets, string, next list equals new array list, diamond operator parentheses, and in the parentheses, list.of with 3 strings pickles, mustard, and cheese as arguments, and print it out. In this code, I create a new array list, and this time I can just pass a list of strings to the static method on list called list.of, and I put that in my constructor parentheses as shown. This is one way to create and populate a small array list in one statement with a few known elements. Let's keep looking at ways to add elements. There is another method called addAll method, which takes any list as an argument. I'll use that next. Groceries.addAll with next list as the argument, and print it. Here I'm adding everything in next list to my first list with the addAll method. The output confirms that the groceries list now has 8 items in it. All the elements in next list were added to my grocery list. Since this video is getting a bit long, let's end it here. In the next video, we'll look more at removing elements and then sorting, as well as making copies of a list. I will see you in that next video.